Pluto, a distant and muddling world, was once a single, honest planet, individual from our planetary family. In any event, disturbing explanations by driving astrophysicists Neil deGrasse Tyson and Michio Kaku brought Pluto back into the spotlight with an astonishing receptiveness. They recommended that this chilly world is on a possible loaded delineation with Neptune. Yet, how could it be that this would be able to work out? Moreover, what may be the results of such a tremendous event? Are we seeing a captivating impacted unusualness? Or is there something different to this approaching endless accident? Go along with us as we review the expected results of a Pluto-Neptune impact. Pluto, a past planet that was restricted to a more unobtrusive individual planet halfway in perspective of its captivated circle, remains a subject of interest and concentrate in the cosmic community. According to consistent figures by driving specialists, Pluto's course is perilously near Neptune's. Leading astrophysicists Neil deGrasse Tyson and Michio Kaku are both raising the alarm of a possibly risky disaster between these two planets that could be a gigantic threat to Earth. Yet, how is such an event even possible? Pluto's attempt around the Sun isn't typical for any other planet in our close-by planetary framework. It requires a dazzling 248 years to finish a single circle. This suggests that since its discovery in 1930, it hasn't even finished one full circle. Anyway, the interest doesn't stop there. Pluto's way is characterized by its essentially twisted shape, going totally from the almost round circles of the immense planets. What makes Pluto's circle fundamentally more bewildering is its tendency, still hanging out there at 17 degrees to the ecliptic plane. The way in which Pluto follows is impressively more over-the-top contrasted with various planets. This tendency and oddity add layers of diverse plan to its orbital example. Maybe, quite possibly, one of the most enchanting parts of Pluto's circle is its mixing with Neptune's. For something like 20 years in each circle, Pluto, as a matter of fact, moves closer to the Sun than Neptune, going against what we would anticipate from their conditions in the planetary gathering. This prompts the common inquiry: why hasn't Pluto slammed against Neptune? The response lies in the gravitational impacts of different planets. The assessment of Pluto's circle started not long after its discovery. Initially, space experts battled to make heads or tails of its extraordinary way in contrast to other planets, whose circles lie genuinely close to the ecliptic plane. Pluto's circle stood apart with its dangerous tendency and inconsistent shape. The secret connected with the confirmation that Pluto's circle, in the grand plan of things, really does to be sure cross Neptune's, is the steadiness of Pluto's circle. Amidst these intricacies, it is proof of the complexities of heavenly mechanics. The three-body issue in space is tied in with sorting out how three objects in space, like Pluto, Neptune, and the Sun, move and impact one another with their gravity. It's like endeavoring to think about where they will go, considering where they start and how they pull on each other. For Pluto's situation, this issue shows how its circle, Neptune's circle, and the Sun's gravity all connect in a jumbled way. Terms like asymptotic libration, scope libration, and the VZK wobbling are part of this problem. As per astrophysicists, what's keeping all planets in their circles is a sort of libration regarding Pluto and Neptune. This term surmises that, at any point Pluto crosses Neptune's circle, its position is consistently something like 90 degrees away from Neptune. This spatial segment is huge in holding their circles back from affecting each other. Degree libration, on the other hand, suggests the upward development of a heavenly body in its circle. For Pluto, this recommends that when it comes closest to Neptune or some other giant planet, it is situated far above their circle plane, contributing an additional layer of security from potential influences. One more fundamental figure in this situation is the VZK wobbling. This is named after three scientists, V.A. Appel, L.V., and K.U. Du, who concentrated on how things move in space. It's about how three space objects, like Pluto, Neptune, and the Sun, pull on each other with their gravity. This pulling impacts how they move. Also, for Pluto's case, the VZK wobbling helps us understand the reason why its way close to the Sun is so strange. Notwithstanding the apparent bedlam, this impacting makes a difference to keep Pluto's circle stable for an incredibly crucial time span. The VZK wobbling shows that, despite the fact that things in space could appear to be wild and conflicting, Specific examples and rules assist with keeping everything set up. These factors assist with maintaining Pluto's circle, guaranteeing it doesn't slam into Neptune or wander off base. This three-body issue affects understanding how these circles change because of how space objects pull on one another. Zeroing in on this helps us concentrate on Pluto, our adjoining planetary framework, and far-off stars and planets. Numerical recreations in the late 1980s uncovered that, in spite of these reliable properties, Pluto's circle is wild, with minor deviations in beginning circumstances leading to tremendous contrasts over a long time frame. Anyway, these strange properties of Pluto's circle have been found to maintain consistency over very significant stretches of time. Later, PC tests have assisted us with understanding how the giant planets like Neptune, Jupiter, and Saturn impact Pluto's circle around the Sun. Neptune has an extraordinary relationship with Pluto, where for each 2 circles Pluto makes around the Sun, Neptune makes 3. This reverberation helps keep Pluto's circle stable. Anyway, Neptune isn't the only factor. Jupiter's gravity likewise plays a tremendous role in safeguarding Pluto's circle. What's more, Saturn helps in that broad region also. These tests show that Jupiter's gravity alone is strong enough to ensure Pluto stays on a dependable way for an incredibly lengthy time, possibly even billions of years. Maybe Neptune, Jupiter, and Saturn are cooperating to guarantee Pluto can keep moving securely in space without running into inconvenience. These unconventionalities are essential in the larger setting of the universe for keeping up with the control and consistency of heavenly bodies. Without these variables, the nearby planetary framework, as we know it, would be a place of much greater struggle and unsteadiness. Bodies like Pluto could, indeed, crash into others or be shot out from their steady circles, setting off a flowing impact on other heavenly bodies. For Pluto, especially with conversations about it conceivably slamming into Neptune later on, understanding its circle is critical. This gives us a more clear picture of the adjoining planetary framework's dynamic nature. The instance of Pluto represents how, indeed, even the most evidently unsteady circles can achieve a state of concordance through the muddled interaction of gravitational forces and orbital mechanics. It also shows the significance of consistent knowledge and analysis of these mannerisms to all the more readily figure out our spot in the universe. Investigating the profundities of space frequently drives us to face the capricious nature of divine bodies, and Pluto's circle is an ideal illustration of this unpredictability. The thought of orbital reverberation, which suggests the touchy reliance of a heavenly body's circle on its underlying circumstances, is clearly illustrated in the case of Pluto. This implies that even slight varieties in the little planet's situation or speed can essentially modify its drawn-out circle. Utilizing programmatic experiences has been unbelievably important for exploration to comprehend how Pluto moves in space. These simulations use complex math to model how Pluto, alongside other space objects like Neptune, pull on one another. By changing small subtleties in the simulations, space experts can perceive how even minuscule changes can have an immense effect on where Pluto winds up. In the late 1980s, these simulations uncovered something really interesting about Pluto's circle. In spite of having systems like asymptotic libration and degree libration to keep it stable, its circle can in any case be fiercely flighty. If you start with even a minuscule distinction in where Pluto is or how quick it's moving, over numerous years, its way could wind up looking entirely different. Regardless of this disorder, Pluto's circle remains stable for billions of years. This suggests that Pluto's excursion around the Sun has a certain order to it, even though it seems turbulent right away, especially when it involves turbulent circles like Pluto's. This presents colossal challenges. The intrinsic nature of these systems suggests that long-term estimates are frequently loaded up with uncertainties. While numerical recreations give an incredible resource for understanding and predicting the future behavior of heavenly bodies, they also highlight the limits of our expectations. These models depend heavily on the precision of starting circumstances and the complexity of the interactions they mimic. Any slight mistake or deviation can radically change results, making exact predictions an overwhelming task. Besides, the violent nature of large circles like Pluto's serves as a reminder of the steadily advancing and dynamic nature of the universe. While we have made enormous steps in understanding space, the illustration of Pluto reminds us how our comprehension of the universe is still limited. Understanding the gravitational impacts of the giant planets on Pluto's circle offers significant insights into the broader dynamics of the close-by solar system. It shows how the presence and position of every planet can have sweeping consequences for the strength and course of different bodies within the system. So, for what reason are noticeable astrophysicists suddenly raising worries about a potential impact between Pluto and Neptune? Despite all these complicated forces attempting to keep such an event from happening, Neil deGrasse Tyson, a prestigious astrophysicist, offers a book-length perspective on the mysteries of our close-by planetary framework, especially the charming illustration of Pluto. Tyson, known for his role in the renaming of Pluto from a planet to a dwarf planet, gives a smart analysis on the developing nature of heavenly mechanics and the public's interest in the disregarded corners of space. What is going on? Pluto's renaming is framed in the ever-expanding knowledge of our close-by planetary framework. He believes the renaming to be not a diminishment, but rather a vital change in accordance with our growing understanding of the many bodies surrounding our Sun. Tyson's approach to divine mechanics is one of constant learning and transformation. He sees the complexities of Pluto's circle, as well as its interactions with Neptune, from a perspective that recognizes the capriciousness of space. He proposes that, while Pluto's circle is steady for now, it could undergo significant movements later on. This possibility serves as a sign of how much we still need to discover about the forces shaping our close-by planetary system.